Good afternoon, everyone. Let us start. Remember, we have been learning Chapter 5, Minerals and Energy Resources. Last time we discussed about distribution of metallic minerals. Today we shall start with a discussion on distribution of non-metallic minerals. Now I will present so last time I told you that I will show a map showing distribution of copper in India. So this is the map showing the distribution of copper, and the same has been uploaded in the WhatsApp group also. I think all of you might have watched it. So here, distribution of copper and bauxite, and see here this area: Khetri copper mines, Alwar copper mines, Bhilwara, Udaipur. Okay, so here also Hazaribagh, then Singhbhum. Now let us start. So today we shall start with this topic, non-metallic minerals, that is minerals which do not contain metals. So we have mica. First I will show you a picture. So this is the mica. Okay, so it shows mica. I think you will be seeing very thin so this is mica, and you are seeing very thin sheets. Okay, see, let us read. So mica is a mineral made up of a series of plates or leaves, which you have seen, okay, in the photograph. It consists of series of plates or leaves. It splits easily into thin sheets, and these sheets can be so thin that 1,000 can be layered into a mica sheet of a few centimeters high. From a few centimeters thick sheet of mica, we can split thousands of very thin sheets. Okay, then about the color of mica, see, color can be clear, that is transparent, black, green, red, yellow, or brown. And properties of mica, let us read. Due to its excellent dielectric strength. Dielectric means having the property of negligible electrical or thermal conductivity, or insulator, okay, or non-conductor. Low power loss factor, then insulating properties and resistance to high voltage. Mica is one of the most indispensable mineral used in electric and electronic industries. So it tells the uses of mica. Mica is used in the electrical and electronic industries because of all these properties mentioned above: dielectric strength, low power loss factor, insulating properties, and resistance to high voltage. And now let us see about distribution of mica. Mica deposits are found in the northern edge of Chotanagpur Plateau. Kodarma, Gaya, Hazaribagh belt of Jharkhand is the leading producer. Okay, Jharkhand is the leading producer of this mica. In Rajasthan, the major mica producing area is around Ajmer. Then Nellore mica belt, okay, in Andhra Pradesh is also an important producer in the country. So this is about distribution of mica, and here this map shows the distribution of mica. Okay, here the star indicates mica. So here Azmir, Beaver, then here Gaya, then Hazaribagh. Okay, so when you are free, see your textbook. Next we have this another non-metallic mineral or rock mineral, that is limestone. I think everybody have seen a limestone rock. Here this is a picture of dolomite. Okay, limestone block. So limestone is found in association with rocks composed of calcium carbonates or calcium and magnesium carbonates. That means limestone, dolomite, these are compounds of calcium carbonates. Okay, so it is found in sedimentary rocks of most geological formations. Limestone is a sedimentary rock that you have learned earlier, and in most of the sedimentary rock formations you will find this limestone. Formation means a layer which has been formed in a particular geologic time. Okay, and you know that limestone is the basic raw material for cement industry and essential for smelting iron ore in the blast furnace. So it tells the use of a limestone. It is used in making cement, and it is also used in the smelting of iron ore in the blast furnace. So this pie diagram shows the production of this limestone, and if you see this, examine this diagram very carefully. So here Rajasthan with a percentage here of 21 is the largest producer of limestone in the year 2016 and 17. So any question regarding distribution of mica and limestone? Okay, if you don't have any problem, let us proceed. Here in this box we shall discuss about hazards of mining. Okay, hazards of mining. See, what are the impacts of mining on the health of the miners and the environment. You know, mining is very, very dangerous to the human health and to the environment. Okay, so let us read. The dust and the noxious fumes inhaled by the miners make them vulnerable to pulmonary diseases. The dust, okay, coming out from the mining areas, and the noxious fumes. Noxious, you know that fume which is very injurious, very harmful to physical and mental health. Very irritating smell. Okay, inhaled by the miners make them vulnerable to pulmonary diseases. Pulmonary diseases means diseases related with lungs. The risks of collapsing mine roofs, inundation, and fires in the coal mines are a constant threat to miners. See, sometimes when we are doing underground mining, okay, in the tunnels, the roof may be collapsed, killing people. Then so in the hole, in the shaft, okay, see here, let us say this is here a seam of coal is here. Here lies a seam of coal. So to take out this coal, we have to dig a shaft tunnel, and here again horizontal tunnel to be dug out to take out the coal. So sometimes the roof here may be collapsed, or there may be flooding here in the hole. Okay, flood water may be entering and thus killing the people. That is what I mentioned book. Then fires in the coal mine, sometime while doing mining, so fire may break out inside the tunnel and killing people. That means mining is very risky. Okay, and another important problem is here: the water sources in this region get contaminated due to mining. The underground water, okay, in this area are contaminated due to mining activities. Then dumping of waste and slurry leads to degradation of land, soil, and increase in the stream and the river pollution. So these are the these problems, okay, created by mining on the environment and on the human health, and that is why mining is known as a killer industry, as mentioned here. Okay, see here, mining is known as a killer industry because of the risks and because of the these problems created on the environment and the human health. So next we have this conservation of minerals, and here in this highlighted area, so it explains why conservation of minerals is needed. Okay, why is conservation of mineral resources necessary? Let us read. The total volume of workable mineral deposits is an insignificant fraction, that is 1% of the earth crust. The total volume of extractable, okay, mineral deposits is insignificant, means a very small, okay, a fraction, that is only 1% of the earth crust. That means we are extracting only a small fraction of the minerals, and we are rapidly consuming mineral resources that require millions of years to be created and concentrated. It means that formation of mineral takes millions of years. Okay, whereas we extract it, okay, we extract the minerals, thousands of tons of these minerals within few seconds or within few these minutes. That means consumption, that extraction rate is very high, whereas the rate of formation is very slow. It takes millions of years to be formed, whereas it extracts thousands of tons of minerals within few seconds or these minutes. The geological processes of mineral formation are so slow that the rates of replenishment are infinitely small in comparison to the present rates of consumption. As I told you that the process of mineral formation is very slow. That means it takes millions of years. But the rate of replenishment, that is why the rate of replenishment is very small in comparison to the rate of extraction, in comparison to the rate of consumption. And that is why we need conservation of minerals. We need wise use of minerals. At the same time, we must know that most of the minerals are finite and non-renewable, cannot be renewed. Okay, once consumed is diminished forever. So that is why we need conservation of minerals. And in the next section you will find how can we conserve minerals. Here some of the methods for conserving minerals are given here. The first one is improved technologies, that is innovation. Okay, improved technologies need to be constantly evolved to allow use of low-grade ores at low costs. It means that we need to innovate new technologies, okay, to allow use of low-grade ores at low cost. This is one of the most important methods for conserving these mineral resources. That is, improve technologies for innovation. We need to innovate. We need to invent new technology which can which allow us to use low-grade ores at low cost. Then another method of conserving mineral is recycling of metals, using scrap metals, and we can collect the scrap metals from the households and we can recycle it. Okay, this is another important method for conserving minerals. And the third one is substitute. That means substitution. Whenever possible, we can substitute, okay, the use of metals by the other products. Say, for example, we can substitute the use of iron pipe, GI pipes, by polythene pipes, PVC pipes, for example. Okay, so these are the three important methods for conserving these mineral resources. Then can you add one more method for conserving these mineral resources? Can you add one more method for conserving mineral resources? Anybody? Nobody is responding. So one more point we can add. Is government policy. Okay, government policy. So this is another method, okay, or legal provision, okay, to control mining activities. Actually, we need to control over exploitation of resources, over exploitation of these mineral resources, and that is possible only by providing this legal control on mining. This is another method you can add. Okay, then we have these energy resources, and uses of this energy is given here, and you also will be knowing energy is required for all activities. It is needed to cook, to provide light and heat, and to propel vehicles, means to run the vehicles and to drive machinery in the industries. Okay, so we need to explain about the uses of energy, and you are also using energy. That mobile phone that you are using, computers that you are using, all require energy resources. So energy resources can be classified into two categories: conventional energy sources, and another one is non-conventional sources of energy. So conventional sources include this firewood, okay, then cattle dung cake, coal, petroleum, natural gas, electricity, both hydel and thermal. So these are examples of conventional sources of energy. And non-conventional sources of energy include this solar, then wind, tidal, geothermal, biogas, and atomic energy. So we shall discuss about it later on. So now we have these conventional sources of energy, and coal is one of the most important conventional sources of energy. It is also given here in India, coal is the most abundantly available fossil fuel. It provides a substantial part of the nation's energy needs. So coal is used, okay, here it tells the uses of coal. Coal is used for power generation, to supply energy to industry as well as for domestic needs. India is highly dependent on coal for meeting its commercial energy requirements. That means in the industries, in the iron steel industries, in the thermal power plants, we use coal and the others. Okay, so coal is one of the most important sources of energy in India. And about the formation of coal, we have learned earlier, coal is formed due to the compression of plant materials over millions of years in the earth's interior. Okay, when plants and trees are buried in the earth's interior, it is compressed, okay, under high pressure and temperature, and after that coals are formed. And so coal is found in variety of forms, okay, in variety of forms, in different types depending on the degrees of compression. Okay, coal is found in a variety of forms depending on the degrees of compression, means depending on the pressure conditions and the depth, okay, and the time of burial. So quality of coal depends on the pressure, then on the temperature, then on the depth, okay, and the time of the burial. And here in this paragraph you'll find 4 important types of coal. The first one is peat. Decaying plants in swamps produce peat, okay. And so peat has a low carbon and a high moisture content and a low heating capacity. The carbon content of peat is less than 40%. Okay, so here I will show you this photograph of peat. So this is peat coal, and here the carbon content is less than 40%, and so it contains a lot of moisture, and when it is burned it gives lots of smoke, okay, and it also produces yellow flame. Next we have another type of coal, that is lignite. So lignite is a low grade brown coal which is soft with high moisture content. So lignite is a low grade brown coal, that is the color of the lignite is brown. And here the in lignite the carbon content is between 40 to 50%. It also contains a lot of moisture, and it also produces smoke, and it gives lots of ash also when it burns. And here these principal lignite reserves are in Neyveli in Tamil Nadu and are used for generation of electricity. So Neyveli in Tamil Nadu, okay, is the largest lignite mining area in India, and in Neyveli lignite is used for generating electricity. So here is the picture of this lignite, okay, so it shows a lignite. And the third type of coal is bituminous, and so this is the coal that has been buried deep and subjected to increased temperature, okay, and it is the most popular coal in commercial use. So this is the most commercially used type of coal. Bituminous is the most commercially used coal. And see, the carbon content of bituminous coal is ranging between 50 to 80%. It contains less moisture and less smoke. Okay, it gives short and blue flame. So here is the picture of this bituminous. So this is the bituminous coal. The color is black but dull. And next we have the fourth type of coal, that is anthracite. So this is the best quality coal. So this is the highest quality hard coal, and here the carbon content is more than 80%, and so it gives short blue, no smoke is produced. Okay, and it leaves sometimes no ash. So here this is the picture of this anthracite coal. Okay, see, it is lustrous, it is black and lustrous, that is shiny. And here these are cloths. Okay, these are cloths. So I will show you another one. So this is also anthracite. So it is black and lustrous, shiny. So this is the best quality coal. And next we have about distribution of this coal in India. In India, coal occurs in rock series of two main geological ages, namely Gondwana and a Tertiary. Okay, so Gondwana series is little over 200 million years old, and Tertiary series only about 55 million years old. Okay, so these are the two types of coal based on geologic age: Gondwana this coal and Tertiary coal. And since Gondwana coal is older, okay, it is better than the Tertiary deposits. And see, the major resources of Gondwana coal, which are metallurgical coal, are located in Damodar Valley, West Bengal. So Gondwana coals are mainly found in Damodar Valley. Damodar, you know, is the name of river. Okay, in West Bengal. And so this map shows distribution of this coal and oils. You may examine when you are free. And Jharkhand. Okay, so Gondwana coals are mainly found in the Damodar Valley of West Bengal and Jharkhand. And Jharia, Raniganj, Bokaro are important coal fields in this region. Then in South India, we have the Godavari, Mahanadi, Son, Warda valleys. Okay, where these Gondwana coals are found. Then about the Tertiary coals. Okay, the inferior quality one occur in the northeastern states of Meghalaya, then Assam, Arunachal Pradesh, and Nagaland. So these are the places where tertiary coals are found. Okay, say tertiary coals are younger than the Gondwana coals, and hence the quality is low as compared to the Gondwana coal, because the quality of coal depends on the these degrees of compression, then the depth of the location of the this material, and the age or the time of the burial. Okay, the higher the pressure, then the higher the quality, and the older the the material, then the higher the quality. And that is why the Gondwana coal is better than the tertiary coals. Gondwana coals are around 200 million years old, whereas tertiary coals are only about 55 million years old. So this is about the uses, then types and distributions of coal in India. Do you have a question from your side? Today attendance is very poor. Are you connected? Okay, then you are not responding, so let us stop here for today and send your names in the WhatsApp group for attendance. Thank you very much for joining my class.